last week. And then we are going to use the concept from confidence interval. Try to test hypothesis. Okay. So when we use statistics, this is like the ultimate goal to see whether or not, whatever sample we have is actually within acceptable range or claim certain stuff. Okay. So for example, based on our, let's say, the data we got, so the average grade for S1, 91 points. Now, if I use the historical mean and the standard deviation, with 91 is within the range. So we use that. I would say, okay, so in this semester, the average grade for 250 will be higher than 91. So we'll have that. We'll have the first. So we're going to do a single population. And like I said, we derive this from, so we know the population mean, and then if we know the population mean, we know population mean, and we know the population standard deviation, and we use this method. And when we don't know the population deviation, so the hypothesis is an assumption about some fact, okay, related to an average or local. So for example, we say the average data used for smartphone is about 1.8. So now, if we have a portion of the double user is 0.62, then so we need to test whether or not is it true that people use smartphone data. I would say, well, I think most people, I would say teenagers use more than 1.8 gigabytes per month. Okay, so our hypothesis now will be we will have to have a group. So we will have a new hypothesis where we will say H0, and we will say the average, the sample will be less equal to 1. And then this hypothesis is the alternative hypothesis. I say, I think teenagers use more than 1.8. So we actually need to test this. And then if we can say not in that range, we say, okay, that's true, like the data is not in that range. So we say we can reject this. Whatever we want to support would be on the alternative. The new hypothesis is some status quo. Either the new hypothesis less equal to something, or equal to something, or greater than equal. Okay? And then alternative hypothesis is the opposite of the new. So if this one is equal, new equal to something, then each one new less So, so we want to test this whether or not the alternative hypothesis is really true. And if we find the null hypothesis is false, then the actual one is true. Okay. So the hypothesis test is like we need to have a conclusion or estimate, okay, on some unknown population period. And usually we put a copy hypothesis to then what we want to theory or want to show. Or like the example depends on. So this test will be used by some company with data used as part of the survey. So they want to support the average data use or we have so if we fail, if we can reject the null hypothesis, if we go, so this will be one step. Whether or not this area. So if our data is outside of this area, then we can check this. Shows maybe average data use more than one. Second option is we think that actually, hey, now people realize how messed up our brain would be if we use too much data. Okay, I don't know if you guys realize that, like, or if you feel like I sometimes feel like I'm addicted to my phone. I have to check my phone once in a while. If not, I don't feel secure. So I want to cut, my smartphone usage. So if I believe, okay, more people have realized the smartphone are good, so we want to lower the, the data usage. So I believe that the data usage has gone down. Then there will have new range. Less than 100. And the last one is a two-step. Okay, we just want to know whether or not the average data usage is 1.8 gigabyte. Okay, so we have to tell whatever within that range that we talked about, that range, then it's within, then we fail to reject. But if it's outside the range, we can reject. Well, we don't think the average usage is 1.85. Statistic. So when we have two terms, mu equal to 1.8 or mu unequal to 1.8, which is 0 is mu 1.8 and then 1 is mu unequal. Then we can see this is that. And then it depends on how we want the confidence level to be. We want this to be 95%. Right? We want this area, middle area, to be 95%. That means each side is 200. Right? if it's 2 cells. Okay. So this is the new hypothesis. And then one tail, it could be this way. So if you think all things more people are using more than 1.8 data every month, so this will be our new. So we believe the data used around here. If that's the case, that means we have to reject the new hypothesis. Means, well, maybe more than. But if we say, well, I think people, want to cut their smartphone use, so they won't use as much data, that will be here. So the new hypothesis will be inside. And then the reject area, this is alpha. But if we both, okay, if we want, this area to be 95%, what is this? 5%, but what would be the 1.645? Yeah. For one tail, this would be 5%. So we have to look it up. I think this is good. And then same as here. So this area is hypothesis cannot be accepted. We cannot say, okay, we failed to reject, so we accept that. We say that, we just say we failed to reject. And either reject or fail to reject. So when we decide how accurate we want it to be, we would have type 1 error, which is a significant error. So alpha also shows that it's when the null hypothesis is rejected, even when it's true. So sometimes some data they might be out of the range, but actually it's maybe there's an outlier or something. 5% of chance that it's actually within the range, but our test shows we have 5% of chance we make type 1. And then type 2 error is we fail to reject the new hypothesis, so it is not true. And the type 2 error is beta. Beta and alpha is complementing each other. When alpha is high, beta will be low. When beta is high, alpha is low. So if we want to minimize the type 1 error, type 2 error will be higher. If we want to lower the type 2 error, type 1 error will be higher. So it's like when someone is guilty, type 1 error is like when someone is not guilty, and then we think. So when someone is guilty and we think this person is not guilty, okay? Type 2 is someone is not guilty and we think he's guilty. So which one is more important? Either or it's not, it's, we don't want either, okay? So, but unfortunately, in statistics, these two are like substitute. But only one way to minimize both to increase the sample size. When the sample size is big enough, it will also to the true. Whenever alpha is up, alpha is down. Then the first thing we are going to do is we know and question. So when we have a smaller sample size, then that's what we do. Okay. If it's smaller than the more than 30, then the population have then we can use this. But if the sample size is then they will just sample. Here's the manufacturing mentioned the average lifetime. Longer than people at least. So what if we select a item and 6 level average is 81. So that means that and then the population standard deviation is 500. Okay? So does that mean that 8120 is significant enough to be considered longer than it? Okay, need to make sure it's given that deviation. So how do we do that? So we can do two. One is calculate the critical Z value. Okay, so the critical Z value basically is to convert that here this is 800, right? And then ours is 80, 81, 81. So we want to calculate this, convert this to be 0. We want to calculate the Z. We convert this into Z. We don't add. And then we'll compare this with the different time. We set it to be 95. This is the confidence interval. Like, so we calculate the error margin. First is the Z value. So what is the critical Z? What is the boundary of the reject region? Okay. So our null hypothesis is mu less equal to 800, and then the H1 alternative mu greater than 1000. And then the significant level here, that's 0.05. Okay, either 0.05 or 95%. This is a 95%. So we calculate this. So we want to calculate, we convert 8120 with the standard deviation of 500, 746. Okay, what would be the Z value? If it's smaller than 1.65, if it's smaller, then we don't reject. Means that the average life form is if it's here, we can reject it. And then, okay, the lipo line is longer. This line, X line is stick. Point 44 is still within the range that's actually considered 800 or smaller, not big enough. Like the 120 greater is not far away with the standard deviation. If the standard deviation is smaller, then it could be here, right? So because the standard deviation is big, so this normal distribution is going to be flat. Because the standard deviation is smaller, it could be this way. Then this. So in this case, we fail to reject. This. This means that it's check. So confidence interval similar to this. So instead of calculating the Z score, now we use the similar approach. Calculate what's this range? What is this? This. We can use the this is 4, 5, and 6. So the Z is this is 8,000. $8,137. So if we want to reject it, we want to claim that the life of the light bulb is actually longer than 8,000. You know, have to like the 36 sample we test life the light bulb should be more than 8137. Then we can say, well, we can reject and we have to mean that light bulb life is less than the light bulb life. Or another thing, well, we can make the sample test bigger. And 81.8 or whatever. This one, mu is greater equal to P. Mu is P. That's so how do we come to this? So we can use. So let's do Z value first. So the Z value will be X R minus Z divided by the R divided by. Oh, 50. So this is the sample population, and this is the sample mean. So we should do -1. 1 is 5%. 5%. Otherwise, so this should be what? -1.6. Right? That's -1. We reject the new hypothesis. And we fail to reject because it's here. This area, because now this is the one. Now, the data might explain that, well, you believe that in average, the data uses 1.8 gigabytes. So, and then we select 47 and 49 sample and 1.86 average use. And the negation 2. So how do we look at the two tab? Okay, so the two tab now is so now the u equal to 1.8. Okay, and then select this one, which side 0 to 1. So now our X bar is 86, 8, 6, and 8. So it's actually outside of this range. Reject. No. All of this 49. Average. So we use the 1.96 times the margin of error, right? So will be A5. I will calculate A6, just a little bit over. But still, we reject it. Even though it looks very close, right? It's 1.86 versus 1.8. We can't just decide based on our feeling and instinct. If we use the numbers, we use the standard deviation. The standard deviation is actually very small. So if that's the standard deviation, then we can do data use increase in not higher than. If you don't know the population standard deviation, we use the deviation. And then we consider using the D-score. Okay. So then you will have to see how big is the sample size. Big enough. 100, you will be very good. Average cost of agent is lower. And this is weighted. For instance, sample of 25. Well, those other ones sample size, the average is here. Now, does look cheaper than 188. Okay. The standard, the sample distribution. So when we calculate T-back, this new greater equal to 1 agent. So we have to go look at the school. Look it up. We are within 0.4. Alpha is equal. Then the T will be negative 1. So now so the T is x bar minus 77. Negative temperature. Then the deviation. The T score and is negative. Actually, rejected. Actually, oh yes. Right. Lower than 1. Is not evident. Check. The confidence interval similar to what we did, and we look up the score of the table. Use this amount. The deviation, which is 5.44 divided by 5. That would be it. For example, any question? This will be long and hold the deviation. This one, and this is and each side. Oh, so this is what you tell. This is division. So negative 2.5. Here, this. Okay. T is actually 0.98. 0.98. In this case, confidence interval very similar. Just okay. We know the population mean and then know the population deviation. So the last one, portion. Very similar to one. So the n times this so the key function is tempo. And this is P is the population of tempo population, and mu is the, and we have for the proportion of delta U G. So one example is that so this is an example. 38. So 238 divided by that's our P. And then from the deviation will be that. What's the complement? So this is one that we want to do. We think that the increase of mu should be greater than which zero. Let's say this like for the chart. We need to calculate this. So 368 and 162 bigger. We still need to calculate error. So error of margin is 0.62, 0.8. This is actually so you will calculate is 0.646 and the P same. We have to check. Okay. Any other question? So that's it for quiz. We will chapter 9. Okay. With all kind of whole. We gave you the quiz. And then next week I will go over and review quiz 7 and quiz 8, 9, and 10. Okay. I also start working